Dear students, this is our fifth lecture of mathematics for chemists. In our previous lectures, we discussed about log and antilog. Today, we will start a new topic that is very helpful for physical chemistry, that is differentiation. In chemistry, we came across so many times differential relations, so we have to do differentiation of some functions, derivative of some functions. So today we will this is the first part of this lecture series on differentiation. So as we have to use a differentiation in chemistry, so we will not discuss about the basics like how the formulas of derivatives that they are derived, but what we do instead, we will use these formulas. In as a chemist, we have to know how to use this formula and calculate derivative, and what are the various applications of derivative that I will cover in these lectures on differentiation. So basically what we will be doing, to apply the differentiation formulas. I will not derive these formulas as it is a hardcore mathematics topic. So we as a chemist, we just need to know how to use these formulas and carry out differentiation if required for our derivations or some numericals. So let us quickly start. I will just be giving you the formulas for differentiation, and I will solve one or two examples so that you can understand the formula. And the best way to remember this formula is to use them. So make a copy or make notes. Try writing these formulas. So write these formulas on a notebook or paper. So whenever you do differentiations, you keep that page with yourself so that you can, whenever you require a formula, you can see that formula and use it. So once you do so many numericals like 10, 100, 200, then you will keep remembering these formulas. And this lecture is especially important for students from medical background, as they don't know do mathematics in +1 and +2, and non-medical peoples, they are already aware of these formulas. So let us quickly start. The first formula is derivative of, this is called derivative, d by dx. A derivative of x raised to the power n is nx the power n minus 1. This is the formula. So if we have to do the derivative of x raised to the power n is equal to n comes before n and x the power n minus 1. That is the formula. So let us now try to use this formula and solve a problem. Suppose we have to calculate d by dx of x cube. Now as this formula says, its value will be first 3 as it is, it will come before, and then x raised to the power n minus 1, 3 minus 1, so it becomes 3x square. So it is very easy to apply this formula. So whenever you get a functions like this and you have to do their derivative, so it will be d by dx of x raised to the power n is equal to nx the power n minus 1. Let us do one more example. Dy by dx of x the power 1 square root of x. Okay, so this can be written as dy by dx x raised to the power 1 by 2. So its derivative will become half, will come before, then x raised to the power half minus 1. So it is half, x raised to the power half minus 1 is minus half. So or it can be written as 1 by 2 x raised to the power half. So 1 it comes in denominator, the power becomes positive, so it is 1 by 2 root x. So derivative of under root x is 1 by 2 root x. So it is quite easy. We have written x square root of x as x raised to the power 1 by 2. Then we have applied this formula, d by dx of x raised to the power n is equal to nx raised to the power n minus 1. So it becomes half x raised to the power half minus 1, so half x to the power minus half. So upon solving it gives you 1 by 2 root x. So please do more practice with other numericals like this, so that you can know how to use this formula and when to use this formula. Both things are important. Now this is a formula that we have to remember. We should also learn how to use this formula and when to use this formula, where this formula is applicable, like it was applicable here. So with the help of this we solved Another problem, derivative of x raised to the power 1 by 2. So that's how we can apply this formula. Now let us move to second formula. It says that d by dx of c is 0 where c is any constant. So you have to remember, derivative of a constant is 0. Constant means it can be any number, 1, 2, 3, 100, 10,000, any number or any other constant. So derivative constant means which does not change. Now x is a variable. Why? Because we can put x is equal to 1, its value is 1. When we put x is equal to 2, its value becomes 2. So a numbers, these are constant or some other constant. So whenever we have to do derivative of a constant, its value will be 0. Now derivative of 2 is 0. Derivative of 100 is also 0, because why? 2 is also a constant, 100 is also a constant. So whenever we have a constant means whose value does not change, then its derivative will be 0. So it is quite easy and quite helpful formula. So that's the second formula that we have done. Derivative of constant is 0. Now third formula, if we have a function multiplied by some constant, then how to do its derivative? Derivative of a function multiplied by constant c, where c is constant, then its derivative becomes c comes out of the derivative. So we just write c as it is, then derivative of fx. So derivative of a function multiplied by a constant, c is a constant, then we can keep this c out of the differentiation, it becomes c d by dx of fx. Now let us try to do one or two examples. Suppose we have to calculate d by dx of 7x square. Now x square is a function which is multiplied by a constant 7. So applying this formula, now here c is 7, fx is x square. So applying this formula, it becomes 7 will come out of the differentiation, 7 d by dx of x square. Now d by df of x square we have already done, so it will become 7, it is 2x the power 2 minus 1, or we can say 7 into 2x the power 1, 2x, so it is 14x. So its value of its derivative is 14x. Here we have applied first formula. If a function is multiplied by a constant and we have to do its derivative, then that constant it comes out of the differentiation, and then we take the derivative of the function. So we have to do the derivative of 7x square, it becomes 7 derivative of x square. So derivative of x square we can calculate is 2x the power 2 minus 1, so it is 2x. So 7 into 2x becomes 14x. That is the answer. Now if we have a derivative of only constant, we have no variable, then its value is 0. We have already discussed. If we have only constant and there is no function attached to it, then its value is 0. If a function is attached by a constant, then the constant comes out of the derivative. So that is how you have to apply this formula. So it is very important formula. Derivative of a function multiplied by some constant c, it is equal to this constant comes out of the derivative, and it becomes c derivative of fx, d by dx of fx. Now let us move to next formula. Now suppose we have sum of two functions where u and v are functions of x. U and v are functions of x, then derivative of u plus v becomes derivative of u plus derivative of v. So this is how when we are given sum of two functions, then how to apply this formula. This derivative goes to individual functions, d by dx of u plus d by dx of v. Now let us try to understand this formula by some examples. Suppose we have to calculate d by dx of 8x cube plus 9x square plus 10. Now we are given sum of three functions, so it will become, applying this formula, d by dx of 8x cube plus d by dx of 9x square plus d by dx of 10. So if we apply this formula, dy by dx of u plus v is equal to du by dx plus dv by dx, where u and v are functions of x. So here we were given three functions, so d by dx of 8x cube plus 9x square plus 10 can be written as dy by dx of 8x cube plus d by dx of 9x square plus d by dx of 10. Now applying this formula, here a function is multiplied by a constant, so it can be written as 8 d by dx of x cube. So we have applied our previous formula, this d by dx of c fx is equal to c d by dx of fx. So we have applied here. So 8 comes out of differentiation. We have applied this formula here. 8 comes out of differentiation, so it becomes d by dx of x cube plus similarly here 9 will come out of the differentiation. 9 d by dx of x square plus, now it is only constant and derivative of constant is 0 plus 0 by, because dc by dx derivative of some constant is 0. Now 10 is a constant, so its derivative is 0, so it becomes this. Now d by dx of x cube is 8 into it is 3 x the power 3 minus 1, okay, plus 9 it becomes 2x the power 2 minus 1. We are applying this formula dy by dx x the power n is equal to nx the power n minus 1. So similarly the next is 0 plus 0, so it becomes 8 into 3 24, 24 x raised to the power 3 minus 1 is 2, 24 x square plus 9 into 2 18, x to the power 2 minus 1 is 1. So 24 x square plus 18x is the answer. So that is the derivative of this 8x cube plus 9x square plus 10 is 24x square plus 18x. So we have taken the help from this formula, from this formula, from this formula, and from this formula. So in one example we have used so many formulas. This u plus v, derivative of constant is 0, derivative of x to the power n is nx to the power n minus 1, and if a function is multiplied by a constant, then that constant comes out of the differentiation. So these are various formulas that we have applied in this example. So please try to do more examples only, then you will learn more. Okay, now let us move to next formula, and you have to remember all these formulas. So if you want to learn differentiation, these formulas actually really quite easy if you do practice. If you don't practice and you try to remember this formula, then it is very difficult to remember these, and when you have to apply you will forget. So you have to see how to apply these formulas, and that you can learn only by practice. So there is no substitute of practice, so you have to do practice, practice and practice. Now let us see the next formula. The next formula says that derivative of function of x raised to the power n. So if we have to do the derivative of fx raised to the power n, earlier we did the derivative of simple x to the power n, it was nx raised to the power n minus 1. So if instead of x we have a function of x, then its derivative becomes n function raised to the power n minus 1 and derivative of this function. That is the formula. So if instead of fx if instead of x we are given fx, then it becomes, its derivative becomes n fx raised to the power n minus 1 function as it is, then derivative of that function. Now with the help of this formula we will prove that derivative of ax plus b raised to the power n is equal to na ax plus b raised to the power n minus 1. So we have to prove dy by dx of ax plus b raised to the power n is equal to na ax plus b raised to the power n minus 1. Now here we have fx is equal to ax plus b. So this is our fx. Now we have to find the derivative of fx raised to the power n. It is n fx raised to the power n minus 1 derivative of fx. Now in this example fx is ax plus b, so it becomes n fx is ax plus b raised to the power n minus 1 dy by dx of ax plus b. So here this all goes with this, so it becomes n ax plus b, and we can write dy by dx of ax plus dy by dx of b, where b is any constant. So it becomes n ax plus b. Inside a derivative of ax is a is constant, it will come out of differentiation a dx by dx. So derivative of x is 1. Remember it, derivative of x is equal to 1. We can also prove x can be written as x raised to the power 1. So it becomes 1 x to the power 1 minus 1. So 1 x to the power 0, x to the power 0 is 1. So it becomes 1. So derivative of x is 1. So a dy by dx of x plus 0. Derivative of b is 0. So it becomes n a x plus b multiplied by a. This is 1. So it just with what is left a. So it can be written as n a ax plus b. Here we have raised to the power n minus 1, raised to the power n minus 1, raised to the power n minus 1. So that is what we have to prove. Derivative of ax plus b raised to the power n is n a ax plus b raised to the power n minus 1. So it is a quite important formula. You can directly remember this. Ax plus b raised to the power n is n a ax plus b raised to the power n minus 1. Even if you forget, there is no need to remember. You can always do this. You can always take help from this relation. Derivative of fx raised to the power n is equal to n fx raised to the power n minus 1 derivative of fx. So by using this formula we have proved that d by dx of ax plus b raised to the power n is n a ax plus b raised to the power n minus 1. So that's how you apply this formula. So please try to do more examples. We will do many examples of such formulas in our next lectures, when we will do practice with more complex functions like log, derivative of logarithmic function, derivative of trigonometric function like sin x, cos x, tan x, or derivative of some exponential function e raised to the power x. So such type of functions we will do practice. So this is just the basic. I am doing taking very simple examples because my today's motive is just to teach you about these simple formulas and how to use them. If you start learning this, then we will move to more complex problems, and there is no problem which is complex. Actually derivative is quite easy. It requires little bit of practice. Now let us move to next question. We have to find a derivative of y, where y is a plus x square root whole square root. Okay, square root of a plus x square root. We have to find dy by dx. It is written as derivative of y. It becomes d by dx of, right here, a plus x square root whole square root. Now let us do, now first put, you can write it as d by dx a plus x square root whole the power 1 by 2. Square root can be written as it is the power 1 by 2. Now applying this formula, this is our fx, consider it as fx. It becomes the derivative of this function becomes half a plus x square root function as it is raised to the power half minus 1 multiplied by derivative of a plus x the power a plus x the square root. So that is what, when we will do its derivative of fx. Now here fx, I have assumed fx as a plus, fx has been assumed as a plus x the square root. This is our fx. Now I have applied this formula, derivative of fx raised to the power n is n fx the power n minus 1 n fx the power n minus 1 derivative of fx. Now I have applied this formula, so you can see by when I applied this formula here, it becomes half function is a plus x the square root raised to the power half minus 1 into dy by dx of a plus x the square root. Now it becomes 1 by 2 a plus x the square root when it comes to in denominator, or simply just I will not skip these steps, so otherwise you will get confused. So it is I am doing step by step so that you don't get any confusion. It is half a plus x square root raised to the power minus half. So half minus 1 is minus half in the bracket. Now we will apply again this formula u plus v dy by dx of a plus d by dx of a plus x raised to the power 1 by 2. This square root can be written as power 1 by 2. Now it can be written as half half. Now when it goes in denominator, it becomes positive a plus x square root raised to the power half. I have kept this in the denominator, so minus half becomes positive. In the bracket, derivative of a is 0 plus its derivative is half. Again applying this formula, half a plus x to the power half minus 1 into derivative of a plus x. Now because we have a function which is a plus x, now it becomes, I will write here, it becomes 1 by 2 a plus x square root whole the power 1 by 2 in the bracket. This is 0, it becomes 1 by 2 a plus x the power 1 by 2. It becomes half minus 1 minus half. When I will take this in denominator, it will become a plus x raised to the power 1 by 2 into, so let us see, into again applying u plus v dA by dx plus dy by dx of x. Now it becomes half a plus x raised the square root raised to the power half multiplied by 1 by 2 a plus x raised to the power half. Derivative of a is 0, derivative of x is 1, so 0 plus 1 is 1, so 1 multiplied by something is something. Now it can be written as, so I will write the answer here, so I will just rub it. Okay, now let us see what it becomes. Okay, now it becomes 1 by 2 into 1 by 2 is 1 by 4 a plus x square root raised to the power half into 1 by this 2 I have multiplied with this 2 into 2 4 a plus x raised to the power 1 by 2. So that is our answer. That is the derivative of, so this is 4, yes, that is the derivative of a plus x square root whole square root. It is 1 by 4 a plus 1 square root whole square root into 1 by a plus x square root. So that is his answer. So it is quite easy actually, just it is little bit lengthy, but it is quite easy. You have to go step by step, don't get confused, just do practice. So that's why I have chosen a little bit complexer problem for you, so that you can learn how to apply these formulas. Now let us do one more example. So it is quite easy. Now we have to find derivative of 1 by x plus 1 square root plus x minus 1 square root. Now here we will apply a approach called rationalization. So first we will rationalize this function. So let us do the rationalization. 1 upon x plus 1 square root plus x minus 1 square root. It can be rationalized as x plus 1 square root minus x minus 1 square root. We choose a denominator, then we just have to change the sign. We have to write as it is. So simply divide by same function, x plus 1 square root minus x minus 1 square root. So it becomes, this function becomes this. So it becomes x plus 1 square root minus x minus 1 square root. In the denominator it is a plus b into a minus b. We have a mathematical formula, a plus b into a minus b is equal to a square minus b square. So it is a very common mathematical formula. So we can apply this relation. So a square x plus 1 square root the square, it becomes x plus 1. So that's why its square is x plus 1 minus square root square of x minus 1 is x minus 1. So we have taken their square. So a plus b into a minus b is a square minus b square. So it becomes you can write it here, it becomes x plus 1 square root minus x minus 1 square root divided by x plus 1 minus x plus 1. When we will multiply this by negative, it is minus x, negative negative positive. So x gets cancelled, so it becomes half x plus 1 the square root minus x minus 1 the square root. So that's, now you can see it was a little bit complex number, but after rationalization it has become an easy number. Now we can apply our differentiation formula and do its differentiation. Now we have to find its derivative. So first what we have learnt, that 1 by x plus 1 square root plus x minus 1 square root can be written as 1 by 2 x plus 1 square root minus x minus 1 square root. Now we have to do its derivative. So its derivative becomes dy by dx of half x plus 1 square root minus x minus 1 square root. So half is constant, it comes out of the differentiation. So it is half. Now it is u minus v dy by dx of x plus 1 the power 1 by 2 minus d by dx of x minus 1 the power 1 by 2. So this can be written as this, because the same applies here. Dy by dx of u minus v is du by dx minus dv by dx. So it was u, it was v. Half I have taken out of differentiation because it is a constant. So it becomes half. Now do its derivative. X plus 1 raised to the power half is half x plus 1 raised to the power half minus 1 is minus half. So why it is minus half? Because half minus 1 is minus half, minus 1 by 2 x minus 1 raised to the power minus half. So I have done its derivative. So you try to apply this formula, dy by dx of ax plus b raised to the power n. This you try to do by yourself. So it is quite easy. Next I will write here. So let me erase this. So these problems actually they are quite easy, just you need to practice a little bit of practice, just that they require little bit of practice, nothing else. And yeah, you will learn this by committing some mistakes. First you will do mistakes, but if you keep on trying, you will definitely, you can definitely learn it. It is not difficult. Now this half gets common, so half into half gets common, it becomes x plus 1 raised to the power minus half minus x minus 1 raised to the power minus half. Half into half is 1 by 4. So it can be written as 1 by x plus 1 raised to the power half minus 1 by x minus 1 raised to the power half. You can leave it here, but you can also solve it can be solved further. So please try to solve and up to where you can solve it. This is also correct, this is also a correct answer, but it is always better to solve further if we can solve it further. So you have to solve it until we get our we reach a step from where we cannot solve much. Now what we can write it here, it as 1 by 4, taking this common, x plus 1 raised to the power 1 by 2 can be written as this, x minus 1 raised to the power. Why I have taken this? Because x plus 1 raised to the power 1 by 2 is x plus 1 square root. Now it becomes x minus 1 square root minus x plus 1 square root. So that is your answer. That is the derivative of this function is 1 by 4 x minus 1 square root minus x plus 1 square root divided by x plus 1 square root into x minus 1 square root. So it was quite easy, it was quite easy numerical. You just need to do little bit of practice, as I am repeating again and again, because only then you can learn differentiation. The only way to learn is to do practice. So please do more practice with these numericals as well as some more numericals. You can find them from your plus 2 mathematics book or from your any physical chemistry book. Some problem there will be chapter on differentiation, so you can try to solve those problems. So that's all for today. In our next lecture we will try to, I will try to tell you the formula when two functions they are in multiplication, like d by dx of u cross v, how to do the derivation, then d by dx of u divided by v, where u and v are functions of x, and we will learn a derivative of some more functions like log x, sin x, e raised to the power x, such type of functions. Okay, that we will learn in our next lecture. Till then, please don't forget to subscribe and share with your friends. Thank you very much.